Hey guys, welcome or welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with my 5th video for the AIME series. Today's problem comes from the year 2020 and it's problem number 5. I hope you guys enjoyed this video and let's get started. The problem states 6 cards numbered 1 through 6 are to be lined up in a row. Find the number of arrangements of these 6 cards where one of the cards can be removed, leaving the remaining 5 cards in either ascending or descending order. So essentially what we have is we have 6 cards numbered 1, 2, 3, 4, 5, 6. And if we take one of these cards or one of these numbers out, the remaining 5 numbers must be in either ascending or descending order. So we must first realize that there are many ways to do this, but the first step is to realize that the number of arrangements going in ascending order is the same number of arrangements going in descending order. So all you have to do is find out the number of arrangements going in ascending order, and then we can just multiply that by 2 to get both ascending and descending. So first, we can start off by finding out the number of arrangements in ascending order. Well, we see that we can take each number in these 6 numbers. I'm just going to start with 2. 2 can have 6 different places. It can be where it is right now. It can be in the place of 1. Okay, you see that I took the 2, which was originally in the second place. I moved it to where there were 6 different options of it being in the first, second, third, fourth, fifth, sixth place. And so technically we now know that for each of these 6 numbers, there are 6 ways that it can be rearranged. So that means we have 6 times 6, which is 36 total arrangements for each of these numbers. If you move 1, 1 will have the first place, it can be in the second place, it can be in third, fourth, fifth, or sixth, and same applies for all the other 6 numbers. That's why it's 6 arrangements for each number. There are 6 numbers, so 36 in all. But we also have to come to realize that as we move each of these numbers, there are many that repeat. These are all considered different arrangements. And so, for example, we just moved 2, right? So now we can move 3. Well, originally it was 1, 2, 3, 4, 5, 6. And then when we move 3, it could be 1, 3, 2, 4, 5, 6. 3, 1, 2, 4, 5, 6. Okay, so I just moved 3 for each of the places, so now we have 6 more. But we see that firstly, the first thing that repeated was simply the most basic one, 1, 2, 3, 4, 5, 6. And so instead of going through each number, we can first do 36 minus 5. And that is because for each number that you move, we're going to have 6 numbers that we move, right? So we're technically going to have 6 of these columns. Now, for each of those, they all have 1, 2, 3, 4, 5, 6. That's kind of the basis where we start. And so for each column, if there are 6 columns, then that means that there are 6 1, 2, 3, 4, 5, 6s. So we have to minus 5 because, again, like we have to keep 1. That's one arrangement. So we have to minus 5 to get rid of the other 5 repeating ones. And then we also see that in these 2, we have 1, 3, 2, 4, 5, 6, 1, 3, 2, 4, 5, 6. These 2 repeat as well. So that means that we can subtract 1 because 1, 3, 2, 4, 5, 6 repeats. And then we can move on to move number 4. And I'm just not going to write out 1, 2, 3, 4, 5, 6 anymore because we've already subtracted 5. Okay, and then when we move 4, we see that 1, 2, 4, 3, 5, 6. And 1, 2, 4, 3, 5, 6 repeat. And so the pattern here is we can kind of see that for every arrangement, if the numbers that you move, for example, 2 and 3 and 3 and 2, if you move these two, they're still next to each other. So that means that for when you move, the first one was when we moved 2. The second one was when we moved 3. So we see that there's always going to be one repeating one because 2 and 3, 3 and 2. There's always going to be one arrangement where these two are next to each other. And then we can write out moving 5. So it'd be 1, 2. Okay, and for this one, we see that 1, 2, 3, 5, 4, 6, and 1, 2, 3, 5, 4, 6 repeat. So essentially, I mean, there's only one more arrangement that you have to write out, which is by moving 6 and also moving 1. So there's 2 more. But you can technically write this out because that's not going to take too long. But also we can figure out the pattern that for no matter how many more arrangements or how many more numbers that we move, either if we move 6 or if we move 1, there's always going to be one more repeating arrangement. So we see here that when we moved 3, there was one repeating, and it repeated with 2, so these two. When we moved 4, it repeated with 3. When we moved 5, it repeated with 4. So that means that when we move 6, it'll repeat when we move 5 once for one arrangement. And so that means that we have to subtract, it'd be 36 minus 5 minus 5. Because we subtracted 1 from when we moved 3, and then once from when we moved 4, once from 5, once from 6, and then when we move 1. So this would be 26. But this is only for when it is in ascending order. So now we have to multiply it by 2 to get 52. And that's our answer.